Okay, this is the second video of dealing with the irrational root theorem and the imaginary root theorem, and we're going to be writing polynomials in standard form when we're given roots of these. Okay, and hopefully you watched the last video. We saw that they came in pairs, and now we're just going to be dealing with a little bit more complex ones. Last video we dealt with ones where we had the roots like this. Now we're going to be dealing ones that have roots like this. So suppose they tell you that you have a polynomial that has roots, let's just use those, at 1, let's just say 1 plus square root 3. They just tell you you have a root at 1 plus square root 3. Okay? So, first thing we want to do, using the irrational root theorem, we know that these come in pairs. So we know if we have a root or a 0 here, we also have to have one at 1 minus square root 3. Okay, that's just what this theorem tells us. And we saw that all the time we work with these. Okay, now I'll just go backwards. So if I know these are the roots, the step that would have got me here, x equals 1 plus square root 3, x equals 1 minus square root 3. Okay, make sure you're taking notes as this video is going through. Now the step before this, these would have been equal to 0. So I've got to move everything over to one side. Minus 1 minus square root 3, minus 1 minus square root 3. So I'll have x minus 1 minus square root 3 equals 0. Minus 1 plus square root 3, minus 1 plus square root 3. X minus 1 plus square root 3 equals 0. Then I know the step before this, I was multiplying these, and they were equal to 0, then I was able to use the zero product property. So I'm going to do the same thing here. So x minus 1 minus square root 3 times x minus 1 plus square root 3 equals 0. And hopefully you could see in your head, you would have gone backwards if you were solving. Now, here comes the fun part. Now we get to triple distribute these guys. Fun. Okay, not too bad. X times x is going to be x squared. X times negative 1 is minus x. X times a positive square root 3 is plus x square root 3. I know some students actually write in different colors for this. I don't know, it's up to you. It's easier for me, I have the board. Okay, negative 1 times x is minus x. Negative 1 times negative 1 is plus 1. Negative 1 times square root 3 is negative square root 3. And then finally, negative square root 3 times x is minus square root 3x. Or you can do x square root 3. Sure, we'll do that. Same thing. They're the same thing. Negative 3 times negative 1 is a positive square root 3. And then negative 3 times, square root 3 times the square root of 3 is the square root of 9, or minus 3, because of the minus sign. Okay. Now if you look at this, some nice things. X square root 3 positive, negative x square root 3. Yes. Negative square root 3, positive square root 3. Yes. So we're left with x squared. Trying to get him out of the way. Then we have a minus x. So negative x minus x is minus 2x. Get those out of the way. 1 minus 3 is negative 2. And this was all equal to 0. So this is equal to 0. And then the last step, we would have had it equal to y. So we can just put the y back. And here's our equation that's going to produce roots at those two. Okay? Okay, so I'm going to put another one up. This one we're going to deal with the imaginary root theorem. Same idea though, except remember from the last video, a little bit of a hint. I squared equals negative 1. So after I put the next one up, pause the video, work on it, and then watch the video as we go through the solution. Okay? Okay, so let's say you had roots at, let's do 1 plus 2i. So pause the video, try it out, and come back. Welcome back. Okay, so if you know you have a root at 1 plus 2i, you know you also have a root at 1 minus 2i by the imaginary root theorem. Now we're going to do exactly what we did last time. To get here, we would have had x equals 1 plus 2i, x equals 1 minus 2i. Bring everything to one side. X minus 1 minus 2i equals 0. Okay? To apply the zero product property, let's take their products. Okay? Great. Do your best friend in the world, triple distributing. Okay? X times x squared, minus x, plus 2ix. Okay, great. Oh, now we do the negative 1, minus x, plus 1, minus 2i. Okay. And finally, minus 2ix, plus 2i, minus 4i squared. Okay, now let's see if anything sums up to 0. I have a 2ix, negative 2ix, 2i plus 2i. Okay, looks like that's it. So I have an x squared, negative x minus x is minus 2x. Be careful, a lot of people think the x's cancel too. But not you. Okay, plus 1, and then minus 4i squared equals 0. But, Mr. Pons, doesn't I squared equal negative 1? Exactly! So you know I squared equals negative 1, so you can make that substitution. X squared minus 2x plus 1 minus 4 times negative 1. 4 times negative 1 gives you a positive 4. So you have x squared minus 2x plus 1 plus 4. Now you can just combine like terms. X squared minus 2x plus 5. And remember, we're not setting equal to 0. We're going all the way back to the beginning. It'd be equal to y. So you should be thinking to yourself, well, okay, what does that really mean? Well, this polynomial has roots at these two complex numbers. Okay? So hopefully you see if you had to find the roots of this, you'd set it equal to 0, do some factoring to get back there. Okay? Might probably use the quadratic formula, but whatevs. Okay. So hopefully this answers some questions you have. Yeah.